So today what we'll be doing is we'll be taking a look at the displaying of data. Now, we display data using graphs, and the information on those graphs can be one of two types. One could be categorical data, as you see here, and that has to do with anything where we can group things into different types, like colors, types of animals, and types of snack food. So in your language, you would call this like a unique group, grupos únicos. Okay? Now, as for numerical data, there's two types of numerical information that you would find on a graph. We would have something that's called continuous data, and we also have something that's called discrete data. Okay? Now, when we're talking about these two different types of data, when we talk about continuous data, this is basically data that can have any numerical value in an interval. So, for example, we could have like 1.1, 1.2, 1.3, 1.5, 1.5, all those different decimals for our things. Now, this would be on either the x-axis or the y-axis of our graph. When we talk about discrete data, these are distinct pieces of data that we're always looking to be counted. Okay? So when we're talking about that, we're talking about this. I'm not sure how to pronounce that, but it looks like dados única que pode ser contado. Now, when we're talking about the different types of data, we're going to be looking at the categorical data, numerical data, and then we're going to decide whether it's continuous or discrete. So when we're using bar graphs, this is one of the most important things you're going to understand. We use bar graphs to basically show categorical or discrete bits of data. So for example, we have all of these bits of categories here. Okay? And those categories are going to be basically described as some sort of percentage of a total amount. Now, if I was looking at this part here would be a category. This part here on this side would be a category. And this part here would be continuous or decimals. So when you think of continuous data, those are any numbers that you could have in between 0 and 1, 5 and 6, anything like that. Now, if I'm looking at this chart here, we have two what you would call pizza graphs. And those pizza graphs are broken up into categories. So that's what we'd use our pizza graphs to show. And you'll notice for this graph on the right side here, we have our label with our percentage, label with our percentage, label with our percentage, label with our percentage again. And now, let's take a look at this third graph we have in this problem here. So, with our histogram, you'll notice one other thing. The histogram basically has spaces in between each of the bars that we've created. That's why we call this a bar graph. A histogram basically has it when all the graphs are squished right beside each other. So if I was looking at this information, the number of children would be discrete because you can't have a decimal of a child. You can't have half a child. And then if you look at all of these, we have 0, 1, or 2, or 3 number of CDs bought. These are also discrete as well because the number of CDs are 0, 1, 2, or 3. They're not broken into categories. These are just the number of CDs that children buy, and we found out in this case there are 14 if we had 3 kids, 3 CDs. Now for this problem here on our right side, the bottom here represents categories, and the side here are all continuous, also known as continuous data, because we can have half of a dollar, things like that. Now, when we talk about histograms are just basically used to display continuous data. Now, if we've got continuous data, let's take a look. The frequency is all discrete. The frequency on the left side is all discrete, but the information along the x-axis, the mark out of 50, could be any set of numbers that we have here. Okay, we can do the same thing for this. Now, when we have a bar graph, as you see here, you'll notice that there are gaps between each of the categories that are labeled along the x-axis. When we talk about this graph here, we have no gaps between each of the columns. This is what we call a histogram. And what we're saying is all the numbers between 0 and 150, all the times we get a number between 0 and 150, we count all those and we use that as a representation, that height as a representation of our solution. Okay.